Hi all, this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic Huffman coding under the design and analysis of algorithms. Let's get started into the topic. So what is Huffman coding? Huffman coding is a technique of compressing data to reduce its size without losing any of the details. This was first developed by David Huffman. So Huffman coding is generally useful to compress the data in which there are frequently occurring characters. So the basic definition goes like this. Huffman coding is a lossless data compression algorithm. The idea is to assign variable length codes to input characters. The lengths of the assigned codes are based on the frequencies of corresponding characters. The most frequent character gets the smallest code and the least frequent character gets the largest one. So this is the basic idea. Let's see how the Huffman coding works. Suppose consider the input string message. It is BCC ABB DAE CC BB AE DDDC. This is the input string that you are going to decode. So here the input string is of 20 characters long. In electronic components, the alphabet is sent through ASCII mode. So the ASCII code for the letter capital A is 65 and we need 8 bits binary to convert 65. So when we convert this 65 ASCII into ASCII code, the binary form of that would be 01000001. So for one letter itself we need 8 bits, therefore here we have 20 letters. So we need maximum of 8 into 20, which is 160 bits. So using the Huffman coding we can compress this thing to a smaller size. Huffman coding first creates a tree using the frequencies of the character and then generates the code for each character. So let's see how it does. So for example, a simulated one. So we have the message, the input string. So first of all, place the counts of each letter. So for A, it takes 3, B 5, C 6, D 4, E 2. So to encode this data, we have to do we are going to use Huffman coding. So once the data is encoded, it has to be decoded as well. Decoding is also done using the Huffman tree. Huffman tree here provides any ambiguity in the decoding process using the concepts of the prefix code. So for example, a code that associated with a character should not be present in the prefix of any other code. So Huffman is done in the following step. So first step is you have to calculate the frequency of each character string. So we have seen it already. Next we have to sort the characters in increasing order of the frequency. They are stored in the priority queue. So here the increasing order is E2, A3, D4, B5, C6. Next one, we have to make each unique character as a leaf node. So each thing would be the leaf of the node. Then create an empty node. Assign the minimum frequency of the left child of the empty node and also assign the second minimum frequency of the right child. So set the value. So for here the minimum value is 2 in the left and 3 in the right. So the frequency getting so if we sum the characters it will be 5. So remove these frequencies and add to the list. Then insert again node. So we have to repeat the steps again and again to form a Huffman coding. So E2 will be the left hand side and A3 will be the right child of the root node 5. Then in the next step we have to combine then between the root node 5 and counts, take the minimum and then add up. Here 5 and 4 are the minimum, so we add them and make 9 as the root node. So continue the process. Now for the left end we have 5 and in the right end we have D4. So continue the process till the Huffman code is not ready. So then after 9, now when we check 5 and 6 are there. So compared to 9, 5 and 6 are the least ones. So take 5 and 6 and form a root node 11 with B5 as left one and C6 as the right hand side. Now 11 is the root node. Now compare the next two things. So 9 and 11 are the smallest one. So combine them, add them the least squares. So 9 plus 7 will be 20. So our left end and right end of the tree is formed for the given character. So mark the left hand edges, and the next process is we have to mark the left hand edges 0 and right hand edges 1 and then traverse from root node to any letter. Suppose, for example, if you had to go to A from root node, so the distance will be 0, 0, 1, and for B 1, 0 and so on. So please note that if the character is occurring frequently, it will be having the less code, and if it occurs very less amount of time, it will be having the maximum number of characters. So this is the idea of Huffman.